Hello, welcome back to Chapter 9, Section 2. We're going to be doing example number 5, which is an application problem. So, and I gotta be honest with this one right here. Sometimes Dr. Berger likes to put problems in that, we want to make sure that we understand, every math teacher's dealt with it. When are we ever going to use this? This is powerfully important. But sometimes the problems that I've seen in the book are just, they're a little bit of a stretch, okay? And the reason why I mention that is because if you get to Mr. Manning's engineering classes where you start talking about ways to build bridges, you might realize that the arch support for a bridge is not always quadratic. So I have a little hard time with this one. But we'll pretend, okay? I don't think Dr. Berger knows if any of you guys are actually in those classes. That's okay, we'll pretend. What they're actually trying to do here is they're saying that this bridge, that the arch under the bridge is represented by this quadratic function. And already look at it. We got negative 0.007, reminds me of James Bond. X squared plus 0.84x plus 0.8. So this is telling me right now that this is something I'm going to need to use this for. All right? Which is fine. What we're asking is, a sailboat is 24 feet tall. The main mast of the sail, the highest point on the sailboat, is 24 feet tall. Is it going to be able to pass under this bridge? Now, of course, and again, it's just one of those cases where we will be doing lots of real problems, real physics problems with quadratics. It's just this one is kind of like, I kind of imagine like the skipper of the sailboat frantically trying to do some calculations to see if he's going to like crash into the bridge or not. So anyway, the math behind it is just what you know though, all right? It's all good. This highest point, which is about right there, is the vertex. And what I want to find out is the maximum. So what's the distance from the water level to that vertex? Now in the section 9.1 we call that the maximum. That's true. What's the maximum height under this bridge that you can sail a boat under? All right. So I need to find the y value of that vertex. How do I find the y value of the vertex? I have to find the coordinates of the vertex, which means I have to use the axis of symmetry. This vertical line I just drew, which represents, I didn't draw the whole line, but I just drew it from like the water to that, is part of the axis of symmetry. Okay, so here's how I do it. My function is f of x equals negative 0.007 x squared plus 0.84 x plus 0.8. Grab yourself a calculator. If you don't have a calculator, there's a way to get one on your iPad, and I will show you how to do that when we're in class. Most of you probably already know how to do it because I think the middle school teachers go through how to get that. If you have your own calculator, it does not have to be a TI-84. It honestly doesn't. This is just the one that I have. But all you're going to do is just do some dividing and some multiplying and dividing and get the axis of symmetry, and then you're going to be doing replacing in here. But I'll show you how to do it with the calculator. Okay, so first of all, I want to find the axis of symmetry. X equals b over negative 2a. So my b is 0.84 and my a is negative 0.007. So, and one thing, if you have a calculator like mine, this one, you have to make sure that you do things in order, or at least tell the calculator to do things in order. So if I do 0.84 divided by negative 2 times negative 0.007, I'm going to get that number. But if I do it correctly, 0.84 divided by parentheses, which tells me to do the bottom part first, negative 2 times negative 0.007. I get that. So be careful. They are not the same. The calculator follows the go left to right. So it'll divide first and then it'll multiply everything by this. And I get this weird number. But what I actually want to do is I want to make sure that I multiply in the denominator first, negative 2 times a, and then take the 0.84, the b, and divide it by what that is. So I have to follow things in order, right? So my axis of symmetry is going to be, I'll write it right here, x equals 60. Now, that I need to keep working to find out what the vertex is, but I just want to point out something, okay? If this arch, it's not an arch, it's a parabola, but if this parabola does follow this function, and it looks like, I know things are not lined up perfectly, but it looks like one of the zeros right here is at x equals 0, then that tells me this distance is 60, and because of symmetry, this distance over here is also 60. At least that's what it seems like I'm doing. Actually, I had to look at the equation. That's not entirely true. All right? So it's actually a little bit more. And I went by, like, whenever I steal these from the book, the printing is always off. But actually, it doesn't go through 0. It actually, right here, the y value is 0.8. So it's not entirely 60. It's going to be 60 and plus a little bit more, but it's approximately 60. I'll put approximately 60 right there. So that's where the symmetry comes in. Let's figure out what the y value is now. So I'm going to take f of 60, and I get negative 0.007 times 60 squared plus 0.84 times 60 plus 0.8. You can put all of that into a calculator like this, or if you have a different calculator, do it one step at a time. You can do 60 times 60, even if your calculator doesn't do exponents. Then you can multiply that by negative 0.007 and get negative 25.2 here. Then I can multiply here, and then I can take that, add that, add that. You can get to it if you have a different calculator than this. But mine actually does it all in one step. Negative 0.007 times 60 to the second power plus 0.84 times 60 to the first power, actually, plus 0.8. And notice I went too far, it went off the screen. That little arrow right there tells me there's more on the left side. Enter. It says 26. So f of 60 equals 26, and my vertex is going to be 60, 26. 26, make it look like a 6. All right, and this is in feet. So that tells me that if I go from this point right here, which actually is not where the arch is, but if I go 60 feet over here and 26 feet up, I'm going to find the vertex. So finally, the last question is, the sailboat is 24 feet tall. It needs to pass under 26 feet. So the answer is yes. With, I don't know why I screwed up the word with, 2 feet to spare. All right, we'll see you in the next video.